Now what is the formula of B? That is gamma P upon rho. Gamma upon rho. P upon rho. So you can see here P upon rho is here. Can we write the in place of P upon rho? Can we write this RT upon N? Yes, we can write. So let's write it. Gamma. What is that? RT upon M. These are actually constant. Mass also means if we are considering any one medium or any object or any solid, so obviously mass will be constant, only then mass will be changed again and again. So these terms are the constant. So we can say that V is directly proportional to the square root of T. So from now you got the speed of the sound in terms of T. So from here you can say that if temperature will increase, then velocity of the sound will also increase. Okay. So how it affects? So for one statement we have done this much things, the derivation we have done. So this is how, the simple formula was this only, gamma P upon rho. We use the gas equation, and after using gas equation we got the speed of the sound wave in terms of the temperature, that is V is directly proportional to the square root of T. Now if you want to find out like it is given gamma RT, some more things are given in your book, so let's have a look on this. So main thing what we have to remember, this only. Main thing is this only, okay? These things just forget it. If you find this is the main thing, because if you will write in exam that speed of the sound depends on the temperature, how you will write like this? No. These things are not in your syllabus. Derivation. Okay, this one derivation is not in your classes. So now next is what? The formula is found to be gamma RT upon N. Okay, this is found. So if temperature means if we are taking out the velocity of the sound at zero temperature. Okay, at zero temperature, then it will be what? Like this it will come, and if you are finding out the velocity at T temperature, we don't know the exact temperature.
So ma'am, that temperature should be in Celsius.
Yes, that's why we wrote here T plus 273. No? This is the conversion. So like this you can, then if means after solving we find out that Vt is equals to, means the velocity of a sound at any temperature is equals to velocity of a sound at zero temperature plus 0.61 temperature. 61. So this is also another equation. Okay, no numericals are there based on these formulas. Okay, you have already done all the numericals. You haven't seen this type of numericals in which they are asking like this. So no, these numericals actually are in higher classes. So we can compare also velocity. Yes. Okay, but I saw all the numericals. These type of numericals are not here. Actually, it is not your syllabus. In syllabus are the speed of factors of the speed of sound waves. Okay, so this is also we can find out if you want to compare that velocity of a sound at 0 Celsius and temperature. So you can easily find out by using this relation. Now next is the effect on speed of the sound wave by density. So from temperature we understood. Let's write here all the factors. We have done which one? Temperature. Okay. So if velocity will increase, temperature will increase, then velocity of a sound will also increase. Now next is density. For density we have a simple formula that Young's gave formula. You can see here also from this Laplace correction formula that it is inversely proportional to the square root of the density. Okay, V is inversely proportional to the square root of density. So if density will increase, velocity of the sound will decrease. Inversely proportional. Fine, these arrows are just telling you the inversely proportions. Now next is humidity. Third is humidity. So if humidity will increase, then density will also increase. Yes, if humidity will increase, then density decreases. If humidity increases, density of moist air is less than the density of dry air. Okay, density of moist air is less than density of dry air. So if humidity increases, increases, then density decreases. Okay, and if density decreases, then velocity of sound increases. Okay, so from here we can easily see that effect of humidity is what? It will increase the speed. More humidity means less density, and less density means increase in the speed of sound. Fine. So this is how your speed of a sound factors on humidity factors in such a way. Now next is effect of pressure. Effect of pressure. So you can see here that this is constant. Gamma it has a fixed value. Then P upon rho. Okay, P upon rho. So V means that if means pressure of the air increases, then density will also increases. It is like that. If you are increasing this quantity, then this is also increasing. Okay, like numerator upon denominator is there. If you are increasing numerator, then denominator is also increasing. So it means that somewhere it gives you the value constant. Okay, constant value. So we find out that the pressure upon rho is actually what constant. Therefore, there will be no effect of pressure. Okay, means the speed of the sound is independent on the pressure. Speed of sound is independent on the pressure, because the value every time if you are changing the pressure, then you are supposed to change your density also, and the result is we are getting in the constant value. Constant value.
Now why is it pressure at low?
Huh? And this is also constant. See, this value is also constant. It is fixed, and this value also will be fixed. So means we will get a fixed value. So that's why the speed of the sound is independent on the pressure. Independent on pressure, because if pressure will increase, then density will also increase. If pressure will decrease, then density will also decrease. So anyhow we are getting only the constant value. Constant value gamma is also having a constant value. That means there is no varying one quantity. We want the quantity which will vary. So here no quantity is varying. Okay, like in case of a density, if this is constant and suppose this is also pressure is 1.0123. If we are taking at normal room temperature, so if we are increasing the density, this is the value. If you will increase this, then it will affect. If you will decrease this, it will affect. But on this is having a constant value, means this is also constant value, this is also having a constant value. No quantity is left for varying. So that's why the speed of the sound is independent on pressure. Next is effect of frequency. Frequency, you can see here there is no use of formula in frequency, so it is also independent on frequency. Okay, speed of the sound is independent on frequency. Frequency is what? Number of oscillation in seconds. Okay, so it is independent of frequency. So speed of sound is independent. Next, last is what? Speed of wind. So speed of wind is means affecting the speed of the sound. If wind is in the direction of the wind is the speed of the sound is in the direction of the wind speed, then speed of the sound will increase. But if they are in opposite direction, because I told you that friction wind should be frictionless. If it will be friction, then there is a chances of the loss of the sound. So that's why speed of the sound will decrease if they will go in opposite direction. So wind. Last one factor is wind. Means this is the speed of the sound, direction of the sound wave, and this is the direction of wind. Then the speed of the sound will increase. But if inversely is there, like wind is here, wind is blowing like this, and the speed of the sound is there, then there will be some loss of the sound because of the friction. So these are the factors which affect the speed of the sound. First one factor is temperature. Speed of the sound will increase when temperature will increase. Then density. If density increase, velocity will decrease. If density decrease, then velocity of the sound will increase. Then humidity. If humidity will increase, then there is a increase in velocity also, speed of the sound. Let's say speed of the sound, velocity, they are saying means if you are giving a direction then it becomes the velocity of the sound, and if you are not giving any direction then it is the speed of the sound. Like here in this case of the wind we can say that it is the velocity because we are considering the direction. So don't confuse with the speed and velocity. Now next is pressure. It is independent on pressure, it is independent on frequency, and on wind it is depending on wind with the direction. If directions are same, so the speed of the sound will increase, but if directions are opposite then speed of the sound will decrease. So these are some factors of the speed of sound waves. They will ask theoretically, so you have to give explanation, okay, a proper explanation. You can directly use this formula, okay, you can directly use this formula. This Laplace formula you should know, you should always remember this Laplace formula, okay, V is equals to under root gamma p upon rho. So from this formula actually we are determining all the factors. Now next is speed of sound, let an observer, okay, this is like in echo. In echo what's happening? Sound is reflecting, okay, when sound is touching it's coming back to also. So if you want to find out the speed of the sound in air, you can use the echo concept also, like distance. Here they take an example that an observer fires a gun on a big target on a hill, okay, and then he uses a stopwatch which is started by any other observer, and they listen echo after some times, okay. So how you will find out the speed in echo? Like distance from here to here, the distance, and the distance of the reflecting, distance of the incidenting the sound wave, and distance of the reflecting of the sound wave, that is d plus d upon t, that is 2d upon t, okay. This is very simple, you have done in 8th class. Now next topic is that infrasonic, sonic and ultrasonic frequencies. Infrasonic and sonic